Okay, so angle bisectors is what we're talking about today. Angle bisector theorem. And we're going to write that down. Angle bisector theorem. Okay. If QS, now notice it's a ray, so I don't have arrows on both sides. If QS bisects angle PQR, comma. There is going to be more. I'm going to add another line of information right here, but before I do that, I do want to draw the picture so you guys can understand what is going on. Okay. So if QS, so QS would be coming out like this. And I'm going to relabel that S in just a second. Okay. So if QS bisects this angle, and I'm going to redraw this one more time only because it's bothering me because it doesn't look all that bisected. Okay. If QS bisects PQR, do you see that? Yes? All right, extra information. PS is perpendicular. Remember the shorthand for perpendicular? PS is perpendicular to QP. Alright, so I'm going to draw a segment right here, and I'm going to do my best to make it a right angle. Okay, so what does it say? PS is perpendicular to ray QP. Do you see that? And last piece, SR is perpendicular to the same or the other ray QR. So same thing here. SR is perpendicular to QR. All right, everybody have this down. So here's our angle PQR. QS bisects the angle. If it bisects the angle, what does that mean about these individual angles here? They are congruent. So I'm going to put congruent markings, and that's given to us because it said it here in the if statement. And PS is congruent to QP, and SR is perpendicular to QR. Perpendicular, perpendicular. Then, any thoughts on what the then is going to be? What segments are going to be equal? PS will be congruent to SR. Alright, so I'm just going to redraw it quickly here. So we're going to redraw the thing just like we did yesterday. Q S P R angle bisector. All right, so if all that happens, then PS is congruent to SR. Okay. It goes through all this, and it's called the angle bisector theorem, but should we know that these are congruent even without the theorem? Ignore those red marks. Let's actually look over here. These two angles are congruent. Do you agree? Mm-hmm. Yes? And these two angles are congruent, yes or no? Mm-hmm. And what do we know about QS? Is it congruent to itself?
Yes.
So could we use angle, angle, side? Could we? Yes, and because of angle, angle, side, these two triangles are congruent, which means corresponding parts are congruent. Does that make sense? So if you had to prove this, could you come up with that proof the way we just said it? Angle, angle, side, because it's reflexive, corresponding parts of congruent triangles are congruent. Got it? I'm going to write here that the converse is also true. All right, what does that mean for the converse? If you have a picture like this and you see that those are equal, then it's going to be an angle bisector. Okay, we'll see some of those in our notes. All right, questions here at all? All right, number 1, find FB. All right, this would be called C. I'm going to put a B here, a D here, and an F there. And I'm going to mark those two angles. There's more, but just write this down for now. Okay. This is 6x minus 3, and this is 4x plus 9. All right, is CF the angle bisector of angle BCD? Is CF the angle bisector of angle BCD?
Yes.
Yes. And BF is perpendicular to CB. And FD is perpendicular to CD. Yes or no? Okay, so that's all over here in this part. So if all that happens, what does that mean about BF and FD? They are congruent. So I'm putting that in red so we know that was not original given information. We concluded that using this theorem. So what is my equation going to be, or what is it going to look like? Perfect. 6x minus 3 equals 4x plus 9. 6x minus 3 equals 4x plus 9. And I still have some kids messing up on their solving, so be careful. Do you want to subtract the 4x or the 6x? 4x, and that gives me what? 2x minus 3 equals 9. All right. Peyton C, give me the next step. Mm-hmm. Not yet. I haven't found x yet. Minus 3?
I mean, plus 3.
Plus 3, good, because it's already minus. So then 2x equals 12, and I'm assuming you're already done with this for you. Okay, so then x equals 6. Okay, so now could you give me the next step? Peyton, what would you do from here? Is this the final answer?
No.
No, what did you do? Plug in x, because they're not asking for x, they're asking for FB. X will help us get there, but that's not the final answer. FB is 6x minus 3. 6 blank minus 3. What do I plug in the blank?
6.
The 6. So I get 36 minus 3. Final answer is 33. Any questions? Make sense? Okay. Number 2. Find the measure of angle KHL and the measure of angle FHL. And I'm going to throw one more angle in there. KHF. Ready to get the picture down? Okay, so draw with me so you don't get too far behind. Yeah, just like that. All right. I'm going to label this K. This is H, F, and L. K, H, F, L. Okay, putting arrows in here. That angle is 6y degrees. And that angle is 4y plus 18 degrees. Okay. Looking at this problem, are we using the original angle bisector theorem or the converse? This is the converse. Why? Because do they have angle markings here in these angles, in these corners? No. That was given information over here. You see that? So the converse would be starting here, concluding that the angles are congruent. So starting at the end, are these two congruent and perpendicular? Then what does that mean about KHL and angle FHL? They're congruent. So I'm going to put them in red so we know that wasn't given information. We're coming up with this using the converse of the angle bisector theorem. All right, so if they're asking for all these angles, what do I have to do first? What do I have to first find? Y. Do you agree we have to find y first? So that'll be what? 6y equals 4y plus 18. I'm going to let you guys solve that now. Alright, what did you guys get? Y equals 9. Are we done with the problem? Or is 9 going to help us find what we're looking for? Okay, measure of angle KHL. How do I find the measure of angle KHL? KHL has 6y in its corner. What am I going to plug in for the y?
9.
So 6 times 9. The measure of angle KHL equals what? What is it? 54 degrees. All right. Is that it? Do I have other angles to look for? What's my second angle that we're looking for? Measure of angle FHL. What's in that corner? What expression is in the corner FHL? 4y plus 18. Now, I'll often have kids ask, well, do I have to plug it in if I know it's going to come out to be 54? Do you? No? Why is it a good idea to plug in? To make sure you are correct. This right here is double checking your work. What do I plug in here where the y used to be? 9. 4 times 9 is 36 plus 18 is, what is it? 54. Okay, so the measure of angle FHL is 54 degrees. Did they come out to be the same? Now, what's the last angle they're asking us for? KHF, which is what? Is it the two angles put together? Okay, so what do we do? 54 plus 54, or if you want to use multiplication, 54 times